Okay, so good evening, everyone. I hope my voice is audible. If
Yes, it is audible.
Okay, thank you. So, today we'll be having our weekly tutorial session for week 7, and I think this is the second last week, and next week we'll be having our last session for this course. So today we'll be having a quick revision about the design for sustainability and what are the design criterias and other factors that we need to consider while designing a sustainable product. And after that, we'll be having a quick previous year assignment section for which we'll be discussing the questions that were asked in the previous year assignment, and we'll be solving those questions in the class. So let's start with the revision of this week. Now, for design for sustainability. So let's have a quick revision about all the terms that we have discussed so far. That is, what is sustainable design, what is sustainability or sustainable development. So, what does sustainable design mean? Basically, it means designing the objects that are from renewable sources. That is, the sources that we from which we are designing the objects. Those must be renewable. Then, designing for the need and function, we should design the product as per the needs and the function that is it needs to be done. Designing the objects that have a positive long-term social impacts and understanding whole Earth's negative impacts that a product may have and turning them into positive. So these are all the factors that we need to have in mind during a making a sustainable design of a product. Then why it is good? Why do we need to go opt for sustainable design? What is the problem with the previous designs that we need to shift towards a more sustainable approach? So we live in an ever-changing world. Looking after our planet is important for the generations that will follow. Reducing our carbon waste helps promote the growth in our planet's ozone layer. So basically, we all know that due to this carbonaceous waste, so we generate a lot of that release a lot of CO2s, and which further leads to global warming and other climate issues like ozone layer depletion. So we need to reduce our carbon waste, and reducing the carbon emissions. That means that our planet is more likely to continue to exist in its current form, because all these climate change factors like global warming, ozone layer depletion, acid rain, and several other factors that disturb our ecosystem, and that is why we need to reduce our carbon emissions. And further, changing our attitudes to what we buy and how we design can help. We should always try to buy products that we need, not just for the sake of buying them. We should consider the fact that, do we really need the product? Then after, we should buy it, because that is how we can reduce a lot of wastage in the environment, using materials that are from resources that won't run out and will benefit the planet. So this is also one factor, that we should use the materials that are from the resources that won't run out. That is the resources should be renewable. That is only when they won't run out, and it then only it can benefit the planet. Developing our design ideas. So, by developing our design ideas and finding ways to reduce the carbon footprint of our products, we can help our planet, and we can improve our design in many ways. So, there are some simple ways to develop our design ideas to reduce their product's impact on the environment. And we all must have heard about these three R's, that is, reduce, reuse, and recycle. So, first one is the reduction phase, that is the most important part. Whenever possible, we must try to reduce our waste as much as we can, and because that will have an immediate impact on the planet. After that, if we are unable to reduce the wastage, then only we should try to go for reuse phase. That is, we should try to reuse the product as many times as we can, so that the waste load can be decreased. And there are many products that things that you can reduce from the materials and components you use through to the energy and time it takes to manufacture your product. And after that, if we go towards the end of life, or the end of use phase of any product, that like if we can't use it any further, then we should try to recycle that product. So that is how we can reduce the emissions and also the carbon footprint or any other waste load on the environment. Now, understanding the life cycle of your product, like this is what we have been discussing so far in these on in all these weeks, like how what is the life cycle of any product. So how can you improve its life cycle and make it last longer? So how can we improve the life cycle of any product, and how can we make it last longer? So these are some of the ways that in which we can make our product last longer. The first one is make it strong. Like we should make products that are strong enough to last for a like to last for a longer period of time. And we should use materials that will last, we should go for more sustainable and more durable materials so that they can last for a longer period of time. Choose the best joining methods you can for the materials that you have chosen. If you are for example, if you are making any furniture product or any other product, so we have different components that are needed to be joined together to form the finished product. So we should use the method of joining uh, which is the best one, so that the material can last for a longer period of time. And try not to mix the materials. Like basically whenever designing a product, we should try to use simpler materials and try to use a single material, or so that during the recycling phase it is much easier to send that product into the recycling unit. Because if a product is more complex and it should if it is having like uh, different types of materials, then what will happen is during the recycling phase, we need to segregate each material separately, and then every single unit will go undergo the recycling process. So that will increase the cost of recycling, and also an intensive labor will be required for that recycling process. So we should try to not to mix the materials. And you should think seriously about what will happen to your product when it is at the end of its life cycle, and how to reduce its effect on the environment. So while purchasing any product, we should in the back of the mind, we should have an idea about what will happen when we reach to the end of its life cycle. And how do we discard this product, or what will happen to like how can we reduce its effect on the environment. Like for example, whenever possible, we should try to carry our own storage boxes. So that way, for example, if you are going to a restaurant and trying to to take some right packaged food, so or like to take away, if we are having a takeaway order, so what we can do is we can carry our own storage boxes. So that way, you all must have seen those plastic storage boxes in which the restaurants pack our food and give it to us. So we can avoid that plastic waste just by taking a simple storage box along with us, which can be used multiple number of times. So in that way we can just taking a small step can reduce a much larger amount of waste that is being generated every single day. So that is how we can reduce the wastage. Now, coming towards the material properties, so embodied energy, this is the energy that any material uses to be made. So glass has a very high embodied energy, and so that's because it uses a lot of energy to be made. And in a similar way, wood has a low embodied energy and it uses less energy to be made. So when using a material, we should think about where it has come from and how did it get to be in front of you. Like what is its embodied energy, how much energy it has consumed during its preparation phase. So understanding the material properties, like what are the properties of the materials that you have chosen, and do they match the requirements of the product? So this is all the factors that we need to keep in mind while designing a product. Develop your own design. So designs are needed to be developed to reduce their impact. So we should think about the ways in which we can change the and develop our design to make it better for the environment. So this is an example of the sheets to show sustainable development of your product. Like what is the need of the product, like how, and then after that, how what amount of waste is being created during its manufacturing, and after that, what is its life cycle, like is this object will be made, and then how long will it last, and after that, after the end of its life cycle, what how will it undergo the recycling phase. So this is a typical sheet that shows the sustainable development of a product. Now, what is sustainability? So this is a definition that we all know, because this we have discussed multiple number of times. So what do we understand by sustainability? So sustainability is the process of development that tries to meet the needs of the present without compromising the ability of the future generations to meet their own needs. So this is what we understand by sustainability. Now, this is a during the industrial revolution, what happened is like, how did we reach sustainability? So this is a typical flow, like what is all in there in the sustainable e- ecosystem. So during the industrial revolution, billions of pounds of toxic waste was released into the air, water, and soil every year, and that is why it created materials that cause concern by future generations to their quality of life, and it produced a large amount of waste, and it also requires endless regulations to simply regulate the rates of damage of points above. So this is all that has happened during the industrial revolution, and this is a typical flowchart of a linear system. uh, Now coming towards the s- economic model of the industrial revolution, basically sustainability stands on three pillars that are economic, social, and environmental. So in LCA, we are more concerned about the environmental part, and we don't go for the economic or the social part of the sustainability. So whenever we try to design a product, if we want it to be sustainable, it should be economically, socially, as well as environmentally sustainable. Then only we can say that the product in overall is sustainable. So this is a cyclical process of sustainable system. So this is see if you want to see any the best example of any process, we can just look towards the nature, because the nature is the biggest teacher, and it has designed everything in such a clear, or in the best way possible, that just look at this example. It is a cyclic system. So we can clearly see that the raw material, like we have this raw material that is formed by the decomposed matter. It is used as a manure or the fertilizer for the products that are like, for example, fruits or anything, fruits or nuts that are being grown on the fields, and these are consumed by the like, for example, we have a squirrel here or any other organism that consumes the product, and after that it generates some waste. So this waste is further consumed by the small insects, or or what we call them as decomposers. So to form again this manure or the fertilizers, like this raw material. So this is a process of cyclic sustainable system. And now, what is sustainability? So, development of Agenda 21 at the World Summit, that is on June 13 of 1992, in which representatives stood for 90% of the Earth's population, and they comprised a single largest gathering of heads of state in history of international diplomacy. And basically, this agenda was grouped into six categories. So, first one is the quality of life on the Earth, then efficient use of the Earth's materials, then the production of our global commons, the management of human settlements, then chemical and management of waste, and then sustainable economic growth. So these are all the six criterias on categories on which the Agenda 21 is grouped. Now, defining traditional engineering, like what all has been changed from the traditional engineering to modern practices. So, in traditional engineering, it was required to solve problems they are presented with to the best of their knowledge within the constraints of the approval authority. and within schedule and financial constraints. So traditionally, during any design process or any in any facilities, what we had some of the constraints, like we had some we need to have an approval with by all the authorities, and after that we had some time as well as the financial constraints also in the earlier times. And that is why engineers search for methods that can maximize the function and minimize the cost to the clients. But because the authorities, they were more they were more linked towards the financial outputs rather than the environmental aspects. So that were the constraints in the earlier times. So traditional engineering was more focused on the maximizing the utility while minimizing the cost to the client. While in the engineering mindset, like what has been shifted in the engineering mindset is that maximizing the social benefit while minimizing the ecological impact. Here more concerned we were in the traditional engineering, we were more concerned about the maximizing the utility and minimizing the cost. Whereas in engineering mindset, now we are more focused on maximizing the social benefits and minimizing the ecological impacts. So this is a shift in the mindset that we have achieved so far. But how do we track the progress? Like what are the what is all progress that we have made so far? How do we track that? So we can track the progress in all the three impacts. Like for the social effect, we can track the progress by performing some community activities or the employment rates or the immigration. Then economic activities like business growth, the employment rates, inflation. The environmental effects can be assessed by beach closures, smog warnings, environmental contaminations, endangered wildlife, birth defects, death rates, and asthma attacks. These are some of the factors that can be used to track the progress that we have made so far. Now, coming towards designing towards the sustainable development. So, during during designing towards a sustainable development, we should be aware of the issues and the impacts which inherently includes well-being of the environment, and then we can comply and go beyond the minimum requirements. We should involve public and communities in decision making and set a mindset to doing what is right, even when appears to be more difficult process. It is a step in the right direction. So we must change the way people think about the sustainability. There's a mindset that achieving a sustainable development is like more costlier process, or if you go towards the greener energy, then it is a bit expensive. So this is the mindset that we need to try to change in people, so that we can achieve the sustainable development. Now, designing towards sustainable development. So, we should step back from the business as usual and find ways to work with nature. We should always include the nature in our designs, like how it is going to impact the nature, or how can we utilize the nature in the best way possible. And we should lessen the environmental impacts. We should try to save the energy and the resources and build on small successes. This is also termed as piloting, and spread the word, that is market your capabilities to both existing and the new clients. So what professionals can do, like for to achieve the sustainable development, what can be done by the professionals? So first is we should design the project to reduce the material and the energy use, and we should try to use renewable energy resources, then maximize the lifespan of the structure, and reduce construction waste generated, then reduce or eliminate the hazardous waste generation, and then minimize the maintenance and services required. So most importantly, we should design the product project to either reduce or eliminate. First is the greenhouse gas emissions, then use of ozone depleting substances, for example CFCs, then the key air pollutants and the indoor air pollutants. So these are all the factors that we should keep in mind while designing a project. And for economical aspect, we should consider all the costs, including energy, water or sewage, chemical or materials, and maintenance and operation, lifespan and replacement cost. So basically, economical aspect not only considers the financial sector, or not only consider the money aspect. Apart from that, it also considers the cost that that we need to suffer, or all the costs that we need to pay in terms of the energy, in terms of the water or the sewage. That is like, if our water bodies are getting polluted, so that is also a cost that we are paying for during the designing of any project. Or in terms of the chemicals or the materials, if the materials are getting wasted, or if material, if it's during the extraction of raw materials, or the during the maintenance operation, or the process, if we are having any losses, so that those are also some costs that we are paying during the designing of any project. Like for example, in projects, in sewage treatment plants, so we can utilize the gas that is released by the digesters for energy purposes. Then we can use heat recirculation from the transformers or the blowers. We can use heat exchangers on sewage effluent, and the plant effluent that is being released from the sewage treatment plants, that can be used for the irrigation purposes. So that is how we can try to reuse, or use the uh, processes, or the what do we say? We should try to use the resources more efficiently. In the urban development, we can do redevelopment of the brownfield sites, where pervious pavements, we should try to make pervious pavements in the parking lot. So what it will do is, if we make the pavement more pervious, then whatever the water that is coming onto the surface of the pavement during the rainfall or any other activities, so it will seep in through that pavement towards the ground, and it will help in recharging the groundwater table. After that, we can use the residential cisterns or constructed wetlands and ponds, so that the problem of water scarcity can be managed. In transportation, what we can do is, we can emphasize on the public transport instead of using like their own private transports. Like everyone is using their own vehicle. Just like, for example, consider in this metropolitan city of Delhi, what people do is, every single person is having his own like individual cars. So if they are trying to travel during the of office hours to their offices, they everyone is using their own single vehicles. So what it is creating, it is creating a huge load on the roads, and like huge emissions are being generated during this process. And due to this factor, a large amount of air pollution is also being created. So that is why we should try to focus on the public transit. And if possible, we should try to travel by either on just foot, like pedestrian travel, or we should try to use bicycle, that is more environmental friendly approach. And then we should find make animal or bird crossing culverts, or try to reuse the materials during the road construction. So these are some of the approaches that we can have in transportation sector. In agricultural and building systems, during in architectural and building systems, sorry. So what we can focus on is, we should consider sun, wind and daylight during our architectural practices. Like while designing any house, we should consider the direction of the sun, and we should consider the direction of the wind. So we should provide vents or windows or doors in those directions, so that we should in during the daytime, we don't need to use any lights or any bulbs for the purpose of lighting. Only the daylight or the light from the sun is sufficient to light the entire house. So that is how we can consider reduce the electrical load on the houses. Then we should maximize the reuse of structures and materials. We should use natural ventilation wherever possible. We should consider low flow toilets and urinals, and consider solar systems to power outdoor lighting, that is parking lots or the walkways. We should use solar lighting to for in that systems. We should also use automatic lighting controls that respond to available daylight. So these are all the factors that we can consider in the architectural and building systems. Now, what professionals can do to upgrade their skills, like to upgrade our skills, what we can do is we should keep yourself up to date. We should research and learn about new products and technologies coming, as we know that every single day we are having a new technology coming up, so we should be updated about them. We should learn from the past project experiences and stay up to date through different conferences and events that are happening, and also through media activities. We can keep ourselves up to date. So, what are the useful tools and incentives, like implementation tools and drivers for that? So, research, government funding, and incentive programs. We have some government funding and incentive programs for the sustainable development, and some other utility incentive programs are there, and green globes or leadership in energy and environmental design credit system. So, this is a lead system. So, lead mission, so leadership in energy and environmental design, it promotes and accelerates the adaptation of the green awareness, and it creates better building and communities or the healthy places to live, work, and play. So this is a lead certification process. At every certification level, we need to have some we need to gain some of the points. For, like, for example, if we are lead certified, we need to have 26 to 32 points. For silver certification, we need to have 33 to 38 points. To gold certification, 39 to 51. And for platinum, 52 or more points are required. Now, lead mission. So credits are divided into six categories. Like, how do we get these points? So these credits are divided into six categories. First are the sustainable sites. Second is water efficiency. Third is energy and atmosphere. Fourth is material and resources. And fifth is indoor environmental qualities. And the sixth point is innovation and design processes. So the lead mission is like every single point is classified here at for all the six categories. Like for sustainable sites, it contains 20% of the total points. That is, total we have 70 points. So it contains 14 points. Like out of 14, how much point we get for our sustainability of for the sustainability of sites. That is in the first category. Second, we have water efficiency. So we have 5 points for water efficiency. 17 points are there for energy and atmosphere, and it is the maximum criteria. Then we have for the material and resources, we have 13 points. For the indoor environmental quality, we have 15 points. And for the innovation design process, we have 5 points. So this is how the points are divided. So what is the benefit of the lead project? So the projects, lead projects are, they use less energy and water. They use materials very wisely. They tend to produce less waste and have longer economic lives. They cost less to operate, and they generate less greenhouse gases and other pollutants. And the occupants are more comfortable in these projects, and the occupants are healthier and more productive in these projects. So, what are the requirements of these lead projects? So, these lead product projects require architects, mechanical engineers, electrical, structural, transportation, the site servicing engineers, and the stormwater management engineers. So, these are all the requirements to conduct to formulate a lead project. Then there's a myth that the green costs more. That is, there's a myth that if you want to achieve a sustainable development, or if you want to consider to construct a green building, then the cost will be more. So this is the costing analysis of the academic buildings or the libraries. So these are some of the lead reports. So the steps for staying on the track include: first is your documentation. So we should be try to formulate the documentation as early as possible, and we should maintain it. Then we should update or monitor the sustainability checklist and have a clear picture of the progress on sustainable goals. Then we have energy or cost models that that should use energy and cost models as design tools. Now, uh, what are the budget pointers? Like we should be more focused on how will we do this rather than on how much will it cost. So we should ask early in the project and consider at every step of design and construction. We should establish team goals, expectations, and expertise, and include specific goals in the program, and align budget with the program, and stay on track with the design and the construction. So, but it will take a collaborative effort to get to where we need to. So, the owners, planners, designers, builders, educators, decision makers, regulators, so these all must find all the means to work together towards a common goal. So this is a summary for the sustainable development, that the world will not evolve past its current state of crisis by using the same thinking that created the situation. This is a famous quote by the Albert Einstein. So it means that if you want to solve a state of crisis, or if we want to go past a state of crisis, first of all, we need to shift our mindset from that state of crisis. And what you can apply immediately is that we should develop a sustainability checklist on the projects, and recommend the sustainable solutions to the clients, adhere to your sustainability principles in our work, and we should use sustainability resources. So these are all the questions that we should ask ourselves while doing any uh, project, or while doing any while designing any project. That if not this way, then how? If not us, then who? Like if it is not, it can't be done this way, then how it can be done? We should also seek for the solutions. If not us, then who? Like if we don't do this, then who is going to do this? And if not now, then when? Like, if this is the high time we need to focus towards the sustainable development, and if we are not doing this now, then when we are going to do this? When all the resources will be replenished, or will all the resources will like uh, get exhausted? Now, engineering design for sustainability. So, engineers play a very important role in global sustainable development by designing the production systems for materials, minerals, chemicals, energy, electricity generation and distribution, transportation, buildings, and other structures, and consumer products. So, okay. So these designs have impacts on the environment, economies, and societies at spatial scales that vary from local to global, and and at temporal scales that vary from minutes to decades. So as engineers create designs, they not only evaluate their designs at multiple spatial and temporal scales, they also embed their designs in complex systems. So this is an example from the transport sector. The field of transportation provides an illustration of the multiple layers of systems in which the engineers create the design. Among the most visible products designed by the engineers are the automobiles, and engineers design the engines, and improvements to the design of a fossil fuel powered engine for an automobile can increase the fuel efficiency, and thus it can reduce the environmental impact of emissions associated with the burning of the fuels. And also it can simultaneously it can reduce the cost of operating the vehicle. So this is how a sustainable design of engines can impact the user as well as the environment. So the size, power, and fuel efficiency of the engine must be balanced with the weight of the vehicle. However, so changes in the engine design must be considered within the entire vehicle system. Further reductions in the emissions and operating costs might be possible by lowering the weight of the vehicle. And the use of materials and fuels by automobiles are embedded in complex fuel and material supply systems. Then developing systems to recycle the materials that make up the automobile at the end of its useful life might improve the environmental and economic performance of global material flows. use of alternative power sources such as biofuels or electricity can impact global flows of fuels, which in turn might impact global flows of materials such as water. And finally, the design of cities that reduce the need for personal transportation could dramatically reduce the environmental impacts of transportation systems and would also transform the social structures. So this is an engineering design for sustainability that can consider a variety of system scales. So for an automobile system, this can impact we have some automobile subsystem, for example, the engines and the paint. It is used to during the manufacturing phase of the automobiles, and to run this automobile, we need to have some infrastructure that is highways or the supply infrastructure that is petroleum industry, and this is related to the social structure as dispersed communities and the businesses or malls that are present nearby these roads and the highways. So the point of this example is to illustrate that sustainable design of engineered system will lead to consideration of multiple spatial and temporal scales and will require that the engineer interact with the professionals with many different backgrounds both within and outside of the engineering. These sustainable design challenges are complex, and the tools for addressing these problems are still emerging. Like we are generating different softwares for the sustainable design of the products. And this lecture will introduce the tools that are currently available, which are a combination of principles and quantitative analysis methods. And next, because sustainable designs must be able to compete in the marketplace, quantitative methods for evaluating and in some cases monetizing environmental externalities will be discussed. So the use of other non-monetized environmental indicators for evaluating the process technologies and product alternatives will also be described, and indicators of social impact for engineering design are only at the initial stage of development. Yet some prototype methods have been proposed and used, and an introduction to this emerging area will be presented. So, coming towards some of the principles of the sustainable engineering design. So, first we have Brundtlet report where we got the idea of this all this sustainability principle or the sustainability process. The definition came from this Brundtlet report only. Then we had some Hanover principles that human systems must be designed to coexist with the natural system. Then Augsburg Materials Declaration, in which integration of environmentally benign design materials and manufacturing overall stages of the life cycle. Then optimization exploitation of raw materials and natural resources was there. Then next principle was the energy efficient production technology and product distribution. Then regenerative energy sources, and then durability, recyclability, and closed loops. So these were all the uh, these are all the terms in the Augsburg Materials Declaration. And then we have Sanderson Sustainable Engineering Principles. So the this the sorry. So for Sanderson Sustainable Engineering Principles, the points that were covered were uh, engineer process and products holistically, use system analysis and integrate environmental impact assessment tools, then conserve and improve the natural ecosystems while protecting the human health and the well-being, then use life cycle thinking in all the engineering activities and ensure that all material energy inputs and outputs are as inherently safe and benign as possible. And the last point, and the fifth point is minimize the depletion of the natural resources, strive to prevent the waste, develop and apply engineering solutions while being cognizant of the local geography, aspirations, and cultures, create engineering solutions beyond the current or dominant technologies, and improve, innovate, and invent technologies to achieve sustainability. And the last point is actively engage communities and stakeholders in development of engineering solutions. So these are all the components that were included in Sanderson Sustainable Engineering Principles. After that, we have the principles of green engineering. So we have a total of 12 principles that apply for the green engineering. So the first principle says that the designers need to strive to ensure that all the material and energy inputs and outputs are as inherently non-hazardous as possible. The second principle says that it is better to prevent waste than to treat or clean up the waste after it is formed. That is, we should try to reduce the waste as much as possible. The third principle says that the separation and purification operations should be designed to minimize the energy consumptions and the material use. And the fourth principle says that the product's process and system should be designed to maximize the mass, energy, space, and time efficiency. The fifth principle says products, process, and system should be output pulled rather than input pushed through the use of energy and materials. Sixth principle is embedded entropy and complexity must be viewed as an investment when making design choices on recycle, reuse, or beneficial disposition. The seventh principle says that the targeted durability, not immortality, should be a design goal. And the eighth principle says that the design for unnecessary capacity or capability, that a one size fits all solution should be considered a design flaw. The ninth principle says that the material diversity in multi-component products should be minimized to promote disassembly and value retention. The tenth principle says that the design of products, processes, and uh, systems must include integration and interconnectivity with available energy and material flows. 11th principle says that the product, process, and system should be designed for performance in a commercial afterlife. And the last principle states that the material and energy input should be renewable rather than depleting. So these in engineering design principles establish a framework for designing more sustainable products and processes. And at first, the changes in the engineering design are likely to be improvements to inherently unsustainable products and systems. I think this you can read on your own. There's no point in reading this. So coming towards the economic performance indicators, so the costs associated with poor environmental and societal performance can be very large. So, and the waste disposal fees, permitting costs, and liability costs all can all be substantial. Wasted raw material, wasted energy, and reduced manufacturing throughout are also consequences of wastes and emissions. The corporate's image and relationships with worker and communities can suffer if performance is substandard. And how can we quantify these costs? So there are some tools that are available for estimating the environmental and societal costs and benefits apart from the economic costs, because they can be quantified directly. We To quantify the environmental and societal costs and the benefits, we have certain tools. So they include traditional concepts such as the time value of money, the present value, the payback period, the internal rate of return, and the other financial evaluation calculations. Then some other non-traditional tools that include the methods for monetizing the environmental costs that are hidden from normal accounting procedures. So the that is in this way the less tangible costs and the benefits can still be monetized by using these tools. In general, the traditional accounting practices have acted as a barrier to implementation of sustainable engineering projects because they hide the costs of the poor environmental and societal performance. So many organizations are now giving more consideration to all the significant sources of the environmental and societal costs. And the principle is that if costs are properly accounted for, management practices that foster good economic and societal performance, it will also foster superior environmental and societal performance. Now, these are some of the terms that are used for environmental accounting. First is your internal cost or the private cost. So these are the costs that are borne by a facility, and internal costs include the cost for the materials or the labor that is there during the manufacturing phase. Then some we have some external costs or the societal costs. On the other hand, these are the costs to the society of the facilities activities. So these, like for example, in the dairy industry, a lot of wastewater is generated, or in the paper manufacturing industry, a lot of wastewater is generated. So this wastewater, if without any treatment, if it is discharged into any nearby lake or pond, then we have a loss of fishable waters. So this is an example of an external cost. Often, environmental fee regulations and requirements act to internalize what would have otherwise been an external cost, so that a facility that produces waste must pay to reduce its quantity or toxicity, or pay a minimum premium for its disposal. So there are two ways, like either you should reduce your waste, like reduce the quantity of waste that you need to discharge, or you can pay a premium for the disposal of such waste. So, a typical management accounting system for a manufacturer would include categories for direct materials and labor, that are costs that are clearly and exclusively associated with the product or service. Then manufacturing overhead, sales, general and administrative overhead, and research and development. So environmental and societal expenses can be hidden in any of these categories, but generally the environmental and societal expenses are considered in overhead costs. So often, even the direct environmental costs that would be assigned to a particular process, product, or activity, such as waste disposal, these are lumped together facility wise, like every industry or every single facility can lump sum the environmental costs. And this is often done because of the practices such as using a single waste disposal company to manage all of a facility's waste. Other environmental costs, such as the cost of filling out forms for reporting waste management practices, are also hidden in the overhead category. Because environmental and societal costs are not traditionally allocated to the activity that is generating waste, some of the benefits of green engineering projects are masked. So, like we have two types of accounting, like full cost accounting, and then we have activity-based costing. So, full cost accounting is a type of managerial accounting in which as many costs as possible are allocated to products, product lines, processes, services, or activities. Then, even though full cost accounting does not focus particularly on the environmental and societal costs, it promotes the improved performance because of the cost of reducing waste and societal impacts for individual process or products are revealed, providing management with a better idea of the true cost. Then we have activity-based costing, which is similar to full cost accounting, except that the costs are allocated to specific measures of the activity. In full cost accounting, we included as many costs as possible, which are allocated to the products. And in activity-based costing, the costs are allocated to specific measures for activity. For example, in activity-based costing, the cost of generating a particular kind of waste per pound of production might be measured. So, estimates of the environmental costs. Not all the environmental costs are captured in the traditional accounting and capital budgeting practices. Nevertheless, some measures of environmental and societal costs are available, providing a rough indication of the magnitude of costs and the variation of those costs among industry sectors. And among the easiest environmental costs to track are the costs associated with treating emissions and disposing of the wastes. No, these expenditures are not distributed uniformly among these industry sectors. So in the next slide, in this slide, we have a table which is showing the sectors such as petroleum refining and chemical manufacturing spend much higher fractions of their net sales and capital expenditures on pollution abatement than do other industrial sectors. So for example, you can clearly see that 2.25% of the sales is expended is spent on pollution control in the petroleum sector, and these costs can be reduced by just by preventing the waste and the emissions by these industrial sectors. So the potential pollution control costs for the greenhouse gases. So estimate control costs for the greenhouse gas for an electricity generating unit, EGU, or the power plant as a percentage of sales and revenues. So I think this is a numeric example. to calculate the potential pollution control costs for the greenhouse gases emission. So the question is, assume that when the EGU uses coal as a fuel and converts the heat of combustion of coal into electricity with 35% efficiency. The heating value of coal is 10,000 BTU per pound and the coal is 85% carbon. The carbon costs $20 per ton to capture and sequester, and electricity can be sold for 0.10 per kilowatt hour. So what will be the solution? So first is the electricity generated per ton of carbon. See, we have given is one ton of coal has 85% of carbon, right? So this is in the question. Uh, how much coal we had? Ton. Okay, so we are calculating per ton the values, right? Per ton of the coal. So one ton of coal has 85% of carbon. Then and to convert this ton into pounds, because we had this value in BTU per pounds. So one ton has 20,000 pounds, right? So we what we did is we just multiplied one ton into 20,000 pounds per ton of carbon divided by 85%, right? So 0.85. And this is multiplied by how much heating value of coal is 10,000 BTU per pounds. So this is multiplied by 10,000 and we know that to generate 1 kilowatt hour of electricity, we need 341 BTUs. So, and this is multiplied by the efficiency of the heat of combustion, that is of coal to generate the electricity, that is 35%. So it is multiplied by 0.35. So now we have 2415 kilowatt hour of electricity that is generated per ton of the coal, by ton of the carbon, right? So the control costs are $20 for 2415 kilowatt hour of the generation. So this much generation leads to, since the electricity of can be sold for 0.10 per kilowatt hour. So we had 2415 kilowatt hour. So this is multiplied by 0.10. So we got $241 in electricity sales. So the control costs are about total 8% of the sales. This is a summary of the environmental costs at the Amoco Yorktown refinery. This is the cost categories, and these are the percentage of annual non-crude operating costs. So in waste treatment, 4.9% is cost we have of the total annual non-crude operating costs. Then for maintenance, we have 3.3%, product requirements 2.7%, depreciation is 2.5%, and some other costs that are there, and the total cost is 21.9%. So of the total annual non-crude operating costs, the 21.9% are are spent in the all these categories. So and this is a summary of the environmental costs at the DuPont Laporte chemical manufacturing facility. And now the total cost assessment methodology. So we have a five-tier approach for the total cost assessment methodology. The tier one includes the cost normally captured by engineering economic evaluations. The tier two costs include the administrative and the regulatory environmental costs that are not normally assigned to individual projects. The tier three has liability costs Then tier 4 has costs and the benefits that are internal to a company and associated with improved environmental and societal performance. Tier 5 have costs and has costs and benefits that are external to a company and associated with improved environmental and societal performance. So these are all the total cost assessment methodologies, and the cost traditionally evaluated in financial analysis are: first is the capital equipment, second is materials. Capital equipment is the all the capital that is spent in the in purchasing of the equipments that are needed to be to for the manufacturing phase, and the all the infrastructure that we need. Then we have materials, then labor, then supplies, then utilities, and of these structures and the salvage value. So these are the traditionally evaluated costs that were included in the financial analysis. Then environmental costs often charged to overhead. So these are what are the environmental costs that we often charge to overhead? First is offsite waste management charges, then waste treatment equipment, then the waste treatment operating expenses and filing for the permits, taking the samples, filling out the sample reporting forms, then conducting waste and emission inventories, then filling out the hazardous waste manifest, then inspecting the hazardous waste storage areas and keeping logs, making and updating the emergency response plans, then sampling storm water, making chemical usage reports, and reporting on pollution prevention plans and activities. So, what are the liability costs? So, the liability costs could include the compliance obligations, the remediation obligations, fines and the penalties, and obligations to compensate private parties for personal injury or the property damage and economic losses, then punitive damages and the natural resource damages. So these are this is a generic product life cycle that's showing the key stages in the product system, key inputs and the wastage and effects of emitted wastes on midpoint damages in the environment and endpoint damage to the human ecosystems. This we have discussed in the life cycle inventory part. So these all are all the inputs and the outputs in the midpoint and the endpoint damages. So that's all for the content for week 7. Now we'll have questions for this week 7. So the first question is, among the three also. So the question is, among the three R's of the material management, which one is the most important? Option A is reuse, option B is recycle, option C is reduce, and option D is renew.
Reduce.
Yes. Okay. So the next question is, sustainable system is a dash system. So option A is non-cyclical, B is acyclic, and C is cyclical system.
Cyclical.
Cyclical.
Okay. Category. Which one printing is delete label sounds. So the question is, out of the following categories, which two are assigned the maximum credit points in lead mission? So
Indoor
option
environment and energy and atmosphere.
correct. Delete it. Mhm. Delete. So the question is, fourth question is, which of the following options are correct? Option A, traditional engineering focus on maximum utility
A.
and minimum cost. Uh, Let me just read the options first because I think some of the students use mobile phones, so the screen is not clearly visible. I'll just quickly dictate the question and after that you may answer. Option B is traditional engineering focuses on maximum social benefit and minimum ecological impact. Option C is sustainable engineering focuses on maximum utility and minimum cost. And option D is sustainable engineering focuses on maximum social benefit and minimum ecological impact. Now you may answer.
B and D.
B and D.
Yes.
A and D.
A and D.
Yes, it should be A and D because traditional engineering focuses on maximum utility and minimum cost, and the sustainable engineering focuses on maximum social benefit and minimum ecological impact. So it should be A and D. Fifth question we have. What are the important properties? So the fifth question is, what are the important properties of sustainable design? Option A, designing a highly sophisticated system. Option B, designing objects that are from renewable sources. Option C, designing for function. And option D, designing objects which have positive long-term social impact.
B and D.
Uh, and B is right, D is right, and one more is there.
Maybe C, yeah?
C. C.
Yes, yes, we should design for function in a sustainable design, right? Six question. What are the first two principles of green engineering? So I'll just dictate the options and then I'll just write the correct answers because this is a bit lengthy question. So what are the first two principles of green engineering? Listen carefully. Option A, target durability, not immortality, right? Option B, all materials and energy inputs and outputs are as inherently non-hazardous as possible. Option C, separation and purification process should be designed to minimize energy consumption and material use. And option D, it is better to prevent waste rather than to treat or clean up waste after it is formed. So, what are the first two principles of green energy engineering?
B and D. B and D.
Correct. So, I'll just write the answer. if anyone wants to refer the notes. Okay, so seventh question is of from what are the point? Okay. So out of the following, what are the endpoint damages if a CFC is emitted from a process and reach the stratosphere? So the options are ozone destruction, option B skin cancer, option C crop damage, and option D is increase in particulate matter in the air.
B and C.
B.
A.
So these are all the endpoint damages. And if we are saying about the midpoint damage, then the answer would be
Ozone destruction.
right.
Both A.
Okay, so the eighth question is uh, lead- leadership in design and distributed system is to what's so the full form of LEAD is Leadership in Energy and Environmental Design Credit System. So is it true or false?
True.
True.
Ninth question. Cost associated with Loss of fishable water due to this contents and internal cost. So the statement is the cost associated with loss of fishable water due to the discharge of pollutants is an internal cost. Is it true or false?
False, ma'am.
False.
Question is last statement is according to Hanover principle, human systems must be designed to coexist with natural systems. Mhm. The statement is according to Hanover principle, human systems must be designed to coexist with the natural systems. Is it true or false? We have discussed this Hanover principle.
True.
Yes, it is true. Correct. So with this, we come to the end of our questions for week 7. And if you guys are having any doubts, you can ask. So this week was a bit of theoretical, more sort of theoretical concepts, and that is why I just revised this very quickly. And also, I'm having some health issues today, so that is why I was thinking of ending this session a bit earlier. So if you are having any doubt, you may ask, or else we can sign off for today.
Regarding exam, we will receive some information, ma'am.
Y- Yeah. Okay. Someone has is asking to upload the rest of the module. Yeah. I think week 4, 5, and 6 was pending. So I'll just by today only I'll just upload the all the 3 modules. Like for week 5, 6, and 7. All the recordings I'll just upload by today only, or maybe by tomorrow morning. Apart from that, if any other. Okay, I think few sessions back, someone has asked me about some like book for this course like for LCA. So I would suggest that you just follow the IS code, that is IS 14040, because that is a standard code for LCA practice, and you can get any design or any LCA from that code only. So there's as such there's no standard book for this LCA practice that you can follow. I would suggest you should be thorough with that code only. Anything else, if anyone may ask? Okay, so shall I end this session for now?
Okay.
Okay,
Okay,
ma'am.
so next week we'll be having our last session. So see you guys. I'll take the next session on Tuesday next week. Till then, take care. See you guys.
Thank you, ma'am.
Thank you so much. Thank you.